All right, you are welcome again. Today, we want to talk about concept of homogeneous function. We want to talk about the concept of homogeneous function. When we say that a function is homogeneous, most especially in differential equation, what does it mean? Now, let's take a look at the formal definition of a homogeneous function. All right. Now, we say that a function f of x, y is said to be homogeneous and of degree m if f of kx, ky is equal to k raised to power m f of x, y. Now, when you have a function and then you pass through or you pass in a constant into this function, and you are able to bring out that constant again, but while coming out, it comes out with degree or with power. So if you are able to bring it out, that means that this function is homogeneous. So you pass in k, in place of x, you pass in kx, and in place of y, you pass in ky. And you are able to bring out the k. And while bringing out the k, it comes out in form of k raised to power a number. So that m is called the degree. And then the ability to pass the constant in and bring it out. Then we say that the function is homogeneous. That is why it is possible. Okay? Now let's take a look at a very good example for you to understand properly what I'm trying to say. Okay, now let's take a look at this. You say, show that the function f of x, y equal to 3x squared minus 4xy plus 2y squared is homogeneous and of degree 2. Now, this question says that we should show that this function f of x, y equal to 3x squared minus 4xy plus 2y squared is homogeneous. And then it is homogeneous of degree 2 we are to show. Now let's go. Solution. We have the function f of x, y 3x squared minus 4xy plus 2y squared. Now let's have our number, our constant k. Let's pass it in this form. We have f of kx, ky. That is to say, in this function, anywhere we see x, we're going to replace it with kx. And anywhere we see y, we're going to replace it with ky. Alright, good. That means we're going to have 3. In place of x, we're going to have kx, but we have squared. Minus. We have 4. In place of x, we have kx, close the bracket, and then in place of y, we replace it with ky. Then we'll put it in bracket. Then we have plus 2. In place of y, we replace it with ky, and then squared. Alright, good. Now, we have 3. Kx squared is the same as saying 3k squared x squared. We have minus. When you say kx multiplied by ky, it's going to give you k squared xy. Is that true? Yes. So here we have minus 4k squared xy plus. Now when you have ky squared, it's going to give us k squared y squared. So here we have 2k squared y squared. Is that true? Yes. Now, after opening the bracket, we have 3k squared x squared minus 4k squared xy plus 2k squared y squared. So from this place, we see that in all the terms, we have k squared. So let's factor out k squared. So when we factor out k squared, we are going to have k squared. After factoring out in the first term, we're going to be left with 3x squared. Then minus, in the second term, after factoring out k squared, we're going to be left with 4xy. Plus, in the last term, after factoring out k squared, we're going to be left with 2y squared. So now, looking at this, that means we have k squared, open bracket, 3x squared minus 4xy plus 2y squared. Close the bracket. So from this place, we can see that we pass in k, and k came out with squared. And then we have our original function. Look at it. It's the same with the original function, f of x, comma y. Hello. You see that it's the same, right? Good. So here now that we have k squared, and then our function, f of x, comma y. So we can see that this function is homogeneous. Then we say, hence, the function is homogeneous and is of degree 2. Hello? We said that the function is homogeneous and is of degree 2. Now let's take a look at the second example. The second example says, show that the function f of x, comma y equal to x cubed minus 5x y squared plus y cubed minus x squared y is homogeneous and of degree 3. So we are asked to show that this function is homogeneous and is of degree 3. Now let's go. Solution. We have the function f of x, comma y equal to x cubed minus 5xy squared plus y cubed minus x squared y. Now let's pass in the constant in this form. We're going to say the function f of kx, comma ky equal to, that means anywhere we see x, we replace it with kx, and anywhere we see y, we replace it with ky. That means we're going to have kx cubed minus 5 in place of x, kx in bracket, in place of y squared we have ky squared plus ky cubed minus kx squared. In place of y we have ky. All right, good. So let's open this bracket. Kx cubed is the same as k cubed x cubed. Then we have minus. When we say kx multiplied by ky squared, it's going to give us k cubed xy squared. Hello, good. It's the same. So that means we have minus 5k cubed xy squared plus, when we have ky cubed, it's the same as k cubed y cubed minus, when we say kx squared multiplied by ky, it's going to give us k cubed x squared y. All right, so we open the bracket and we have k cubed x cubed minus 5 k cubed xy squared plus k cubed y cubed minus k cubed x squared y. All right, good. Now we see that in all the 4 terms, we have k cubed in it. Let's factor out k cubed. So we factor out k cubed in the first term, we are going to be left with x cubed. And when we factor out k cubed in the second term, we're going to be left with 5xy squared. Plus, in the next term, factor out k cubed. We're going to be left with y cubed. Minus, in the last term, factor out k cubed. We're going to be left with minus x squared y. All right, good. So after factoring out k cubed, we discover that the function that we have in the bracket is the same as the original function that is given to us. Hello, is the same as the original function that is given to us. So that means we say k cubed multiplied by our function f of x, comma y. So if we succeed, in writing k cube f of x comma y, which we did, we see that and we say that the function is homogeneous and is of degree 3 because we have k cube. So in conclusion, we say hence the function is homogeneous and is of degree 3. All right? Yes. Thank you very much for watching. Please, let's take some examples of homogeneous differential equation. See you. Stay blessed.